What we're looking at here is how we can digitize sound. So sound is an analog wave and computers need to store something in binary, so we need to make it digital. And so here on the left what we've got is a typical sort of looking sound wave, and this is the amplitude, so how big the sound wave is, and this is time running along the bottom. Now there are two concepts or two ideas which help us with digitizing it. And the first one is known as the sample interval, or this is also known as the sampling rate. And what this deals with is how often am I going to take a sample of where that sound wave is at the moment. So let's say that we take a sample here, and we're going to take a sample maybe every 1/10 of a second, and so it will be something like this. So I'm going to take 5 samples of what this sound is doing. And the other one is the sample resolution. And this is how accurate are my numbers going to be here for the amplitude. So let's take a sample resolution, and we'll have one up here, and we'll have 5 different samples that we can take on the resolution. To give some kind of comparison, it would actually be 16-bit if we use a CD. So 16-bit is 2 to the power of 16. So if I take 2 to the power of 16, then I get 65536, and that magic number appears again. And so 65536, this is the resolution which I have on a CD, so how many positions on that wave that it will be sampling at. So in here I've only picked 5, so a very low sample resolution, and I've got 5 for my sample interval. So what will happen if I label these up as 0, 1, 2, 3 and 4? So what will happen is it will take a sample at this point here, and so that will come out, and it will have to approximate, and so it's close to 1, so that will come out as 1. So at time 1 I get the resolution of 1, and at time 2, which is here, sorry, that's not resolution, that's amplitude, so how big it is. So at time 2 I get 4. At time 3 I get 2. At time 4, and this is again close to 1, so at time 4 I get 1, and at time 5 I get 2 again. Now remember what this original wave looks like. If we don't sample very often, or we have a very low resolution, then look what happens when we convert. So this is an analog to digital conversion on the left. What happens when we do the digital to analog conversion on the right? And this is the wave that we're going to get. So first of all we're going to have 0, 1, 2, 3, 4, and we're going to have the times 1, 2, 3, 4 and 5. So at 1 we're getting 1, 1, which is here, and at 2 we're going to get 4, which is up here. At 3 we're going to get 2, which is here. At 4 we're going to get 1, and at 5 we're going to get 2. So all of a sudden this lovely smooth curve which we have here, which has all of the fidelity and all the intricacies of this sound, suddenly gets put into these harsh lines here. And while that does look somewhat similar to the original wave, it doesn't have any of those nuances, and that's why when you have very, very low quality sound, so a low resolution or a low sample interval, like you have on a normal telephone, for example, that's why music played through a telephone sounds really bad, because it's a low sample rate and it's a low sample resolution. Obviously, if you do that though, if you have low sample rates and low resolutions, then you're going to get a small file size. Now let's look at what happens if we were to take a slightly more accurate approach to this. So this time we'll try again, and this time we'll be a little more accurate in what we do. So let's take 10 samples. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Actually, let's go with 11 just to get the top there. And let's go with 11 samples here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So just over double the resolution and the sample rate. So 5, 6, 7, 8, 9, 10, and 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So the same process this time, exactly the same idea. So at 1 we have 5. So when t is 1, the amplitude is 5. When t is 2, it's 4. I'm just going to do these by sight. So 3 is 8. 4 is 11. 5 is 9. 6 is 7, and 7 is 5. 8 is 3. 9 there is 5, and 10 is 6, and the last one 11. 11 there is about 7. Okay, so let's try and plot these. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so we're plotting 1 as an amplitude of 5, and we're plotting 2 as 4. 3 is 8. 4 is 11. 5 is 9. 6 is 7. 7 is 5. 8 is 3. 9 is 5, 10 is 6, and 11 is 7. And so if we now do joining these up, and remember this is still nowhere near the accuracy which you would have playing on a CD, which would be sampling 16 bits, so 65,000 would be the number of bits up here. But if we compare the two, then we can look at what the old one was and the new one. There's not a huge difference between the two. We haven't got it perfect yet, but we can see as we start to sample more closely, and as we start to have a sample interval and a sample resolution which is better, so we get more accurate in the curves. And slowly we start to see things, so if we were to increase the sample rate and increase the resolution, we would start to pick up things like these small curves here, which haven't yet managed to be picked up.